All right. So significance tests for a difference of means. Yesterday we did confidence intervals, so now significance tests. So your null hypothesis is typically that the difference is 0. It's not always assumed to be 0, but most of the time we assume no difference, okay? And we're trying to prove a difference. And you can also write that as equal, right? Those mean the same thing. So the difference is 0 or they're equal. And the test that you guys are going to use on your calculator is the 2-sample t-test. So don't forget, when we're doing means, we use t, unless for some weird reason we know the population standard deviation. All right, but we typically don't. So means are t's, the proportions are z's. All right. So this formula, I'm pretty sure you guys wrote in your notes the other day already. So the test statistic, so the statistic is what we get for our difference from our sample means. So the difference in our sample means, right? The parameter is the true difference, so usually we put 0 right here. And we're dividing by the standard deviation of the statistic, which this is the new formula that you guys learned. So you square the standard deviation divided by the number in the sample plus the other standard deviation divided by the number in the sample, okay? Again, this is on the AP sheet, the formula sheet, except for it uses theta, but you need to substitute in the standard deviation from the sample if you don't have the actual standard deviation. So let's try one of these lovely problems. Does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to 2 groups, so 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. And the experiment was double-blind, so nobody knew what anybody was taking. And the response variable is the decrease in systolic blood pressure for a subject after 12 weeks in milligrams of mercury. An increase appears as a negative number. Here are the data. So calcium people, placebo people. So do the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. All right, so we need to do state, plan, do, conclude. So our state, we identify our mu's, right? What we assume the true mean to be, and we need our null hypothesis and our alternate hypothesis. All right. So mu1, be careful what you define as what and how you set up your alternate hypothesis, right? So on this one, mu1 is the true mean decrease in systolic blood pressure for healthy black men like the ones in the study. So again, don't forget, like the ones in the study, when you're doing an experiment and we don't have a random sample of people, we do have random assignment, but these people volunteered to be a part of the study. So like the ones in the study who take a calcium supplement. So because mu1 is the people who take the supplement, we're hoping for better results, right? So mu1 minus mu2 has to be positive. So mu2 would be the same thing, except for the people who take the placebo. And then don't forget to say, look what I wrote, stats instead of state. I was like, what? All right, state. We'll use an alpha equals 5% significance level since they didn't tell us. So if they don't tell you which one to use, you guys use that lovely 5%. All right, so plan. What's the name of the test? Good. 2-sample. T, because we're doing means. T-test for difference in means. And how come not interval? Because we're not doing confidence intervals, right? So this one's a test. And we check random, but this time we have to have what else? Okay, but it's not really on this one. It doesn't matter. We just have to have randomized groups, right? We have to randomly assign who goes where. And so, yeah, random assignment is what you're looking for. And we do have independent groups, okay? And then we have the 10% condition. What do you guys think? Do we check it? Nope. You don't actually have to check the 10% rule when you're doing an experiment, so don't forget that. No need to check. So we do have to check large counts. So we do not have enough people, right? We only have 11 in one and 10 in the other. So what are we going to have to do? Look at those lovely graphs. I do want to show you guys something. So I put the data in, so calcium people, placebo people, and you can actually put the graphs on one page, so I do want to show you that. So when you're doing the test. So add variable, we've got our calcium people, and I'm going to do a box plot. You can do whichever one you want. I'm going to do a box plot. And I want to put them next to each other. So go to menu. Let's see, which one is it? Right here. So plot properties, you guys. So this is new, plot properties. And if you go to add X variable, you can add a second graph. And it'll do both of them side by side. So make sure, again, that you don't just do it on your calculator and not write it down. You have to write it down. You have to label the axes. Make it good, especially when you're actually taking the AP test, okay? Again, the two lovely graphs have no strong skewness and no outliers. All right, that's what you're looking for. No strong skewness and outliers. So large counts, we check the graph. You do want to write that down. Yes, Jake. Yeah, yes. All right, and then we've got do. So not a confidence interval anymore. Now we're doing the test. So we need to find the test statistic. I would like you to, again, show me what you plug into the formula and then do it on your calculator. So we're looking for the t statistic on this one. And we do first x bar minus x bar. So our two differences, well, they didn't give it to us this time. We had to actually calculate it from here. So again, make sure you know how to do the one variable statistics for each one. You guys remember that, right? So if I do calcium, I get 5. All right, and then you go through and do the other one, and you'll get a mean of negative 0.273. By the way, you are subtracting in this one a negative 0.273 for that second mean. All right, minus the parameter. The parameter is that we assume no difference. So 0 divided by the standard deviation. Again, you have to use your calculator, and you need always the S, right? Don't use the other one, use the S. So 8 point, we'll do 74 squared divided by the number of people in the study. So this one was 10. Our calcium people had 10. All right. And again, you'd have to do one variable statistics for the other one, which gives you a standard deviation of 5.90. And the second group had 11 people. Okay, calculate that out, and we get 1.604. So if we were going to do TCDF, we would need degrees of freedom. All right? You can do the conservative approach. If you're doing the conservative approach and you do TCDF on your calculator and you use that score up to 1,000, yeah, what's the number you'd plug in? 9. Okay, the smaller of the two, so you have 10 and 11, smaller one's 10, and you have to minus 1. That's the conservative approach, right? But the way that you should probably do it is the test on your calculator. So you might want to take your calculator out. make sure you know. And the cool thing is you don't have to know all the different numbers. You can use the lists if you want to. Either way, though, works. So let's go, new page, add a calculator. So you guys probably won't plug all this in because you don't have all the data already plugged in. But make sure you know where it is. So again, we are not doing confidence intervals anymore. We're doing stat tests now. And we're looking for the two-sample t-test. So again, these two are for means. These two are for proportions. So make sure you always pay attention to that. And typically we do the t-test. And then if you want to put all the data in, or if you want to put the data in, that comes from your list. So that's what I'm going to do. The stats means you have to know X1 and S, which we do know because I already calculated it. But if you do it this way, you can just leave them as your lists, calcium, placebo, and then I'm looking for the calcium giving us a better result, so greater than. Make sure we got the same answer. So my T, 1.604, all right? We're looking for a p-value here, and then you have to state degrees of freedom. Don't forget to write that down. So my p-value is 0.0644, and write down degrees of freedom, 15.59. So again, you need three things on the do. Oh, I do want to see this formula, though, so that you recognize it on multiple choice. Yes? No, I don't know why. I did learn, you guys, that you can actually do this on the lists, which is kind of cool. So if you're in the list page and you go to menu, statistics, it has all the same stuff. If you like want to do it on the list page, I don't know. Yeah. Yay. All right. And so, of course, conclude. So this p-value is 0.06, right? That's greater than 0.05. So because the p-value is greater than our alpha, we fail to reject the null. The experiment does not provide convincing evidence that the true mean decrease in systolic pressure is higher for men like these who take calcium than for men like these who take a placebo. Okay? Part B says to explain what the p-value means. So you guys, a lot of people actually did miss this on the last test. So make sure you understand what the heck the p-value is. So always, 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 assuming the null is true, there is, whatever your p-value is, there's that probability of getting, and in this case we're doing a difference in mean blood pressure reduction for the two groups, calcium minus placebo, of 5.273 or greater. So where did we get this 5.273 or greater, you guys? Where'd that come from? Well, right here. This is what we got in the sample. When we subtracted, it ends up being plus, right? 5.273. How weird is it to get that difference? So this p-value tells us what the probability is that we get a difference that great, okay? So just by chance alone. So if the null is true, the p-value is the probability of getting the difference that you found in the sample. Does that make sense? Okay. You guys already did that. So what's the difference between a paired T procedure? You guys were asking about this the other day, right? Difference between paired T procedure, that's what we learned when we just did one list. We went ahead and subtracted the data, right? And we did the difference, but we went ahead and subtracted, so it was still one sample versus a two sample, all right? So use paired T procedures when you have the same subjects doing two different things. So maybe all of us like take a shot of coffee, and then half of us do that, and then half of us don't, and then we switch, right? But everybody does the same two things, so you go through the experiment twice, all right? So it's the same subjects. Or if you have matched pairs, it's like having the same subjects. So if you match up like twins or something, and you have one do one thing and one do the other thing, think of that as like having one set of subjects do two different things, okay? We're going to use the two sample T procedures when you have two distinct groups. So just like the last problem, we had a group of 10 people we had do one thing, we had a group of 11 people we had do the other thing, and then we compared them. Make sense? So let's do some problems and see if you get it. So decide which one you're using, all right? Paired T procedure or two sample. Separate random samples of male and female college professors are taken. We wish to compare the average salaries of male and female teachers. What do you think? Two sample because we're doing separate groups. All right, males and females. Two separate groups, so two sample T procedure. All right, to compare the average weight gain of pigs fed two different rations, 9 pairs of pigs were used. Pairs of pigs. The pigs in each pair were litter mates. So each pair is similar. A coin toss was used to decide which pig in each pair got ration A and which pig got ration B. What do you guys think? This one's paired T procedures because you have matched pigs that are supposed to be really similar. So it's like having, think of it as having one pig do the same thing. Or do two different things. Make sense? Jake? What's the difference? What? You actually subtract them and you just do one sample. Yeah. So the test would be the one sample T test. All right, to test the effects of a new fertilizer, 100 plots are treated with the new fertilizer, and 100 plots are treated with another fertilizer. A computer's random number generator is used to determine which plots get which fertilizer. What do you guys think? Paired or two sample? This is two sampled. You have different plots. They don't say anything about them being side-by-side matched ones or anything. All right? Makes sense, you guys? Hopefully it does.